welcome back to question 2. We're going to do parts 2 and 3, and this is still the June 2012 paper, C3. And it's asked us to use the iteration formula we worked out in the first part to find the values of x1, x2 and x3 to 2 decimal places. And what we can do is we know it's told us that x0 equals 1, and that means that x1 will equal the root of 4 into 3 minus 1 over 3 plus 1, and we can just look at that and actually see that that's going to be root 2. But what we can do for iteration questions is the value of x0, just type it in on your calculator and press equals, and you should get just 1 and 1, or 1 equals 1. And then what you can do is set up your equation to look like this in your calculator. You would have the root of 4 into 3 minus aunts over 3 plus aunts. And what that means is that every time you press the equals button, it will give you the next value of x. It will give you the next value of x. So for x1 to 2 decimal places is going to equal 1.41. And if we do that for the rest, we get x2 to be 1.20 and x3 to be 1.31. That's all to 2 decimal places. There's part B. I'll just do part C in this space. Right, so part C. And it's asked us by choosing a superinterval to prove that alpha equals 1.272 to 3 decimal places, where the root of f of x equaling 0 is alpha. And that means that if we plugged in the actual value of alpha to the f of x equation up here, we would get an answer of 0. But it's asked us, because this value may be quite long, and it may not actually have an end, that to 3 decimal places, it's asked us to prove that that will be our answer. So what we can do is we can plug in to f of x the upper bound, which will be f of 1.2725, and we can plug in the lower bound. And what do I mean by the upper and lower bound? I mean the biggest value that will round down to 1.272, and the lowest value that will round up to 1.272. So that's going to be 1.2725 and 1.2715. And what we get is, if we plug these values into the equation at the top, we get that this is a very small positive number, I'll leave it in standard form because that's how my calculator left it, and this as a very small negative value. And what that has proved is that alpha will equal 1.272 to 3 decimal places, and that is because between the upper bound and the lower bound there is a change of sign. And with your answer in the exam, you would have to explain just a small sentence saying the upper bound equals this, the lower bound equals this, there is a change of sign, hence to 3 decimal places alpha will equal this value. Thank you for watching, and join us for question 3.